In my previous videos, I talked about how to build a machine learning model, how to train a machine learning model. In this video, I'm going to talk about how to validate a machine learning model. In machine learning, model validation is referred to as the process where a trained model is evaluated with a testing dataset. The testing dataset is a separate portion of the same dataset from which the trained set is derived. The main purpose of using a test dataset is to test the generalization ability of a trained model. After we construct our initial model, we'll come here to train the model, to validate the model, and then go back and adjust the parameters and start the training and validation process again. After we finish this training and validation process, we will select an optimal best model, and then we will perform model testing. Whenever we fit a machine learning algorithm to a dataset, we typically split the dataset into three parts: training set, validation set, and test set. We have this as our original dataset, and we will split this original dataset into training set and test set. And then we will use this training set for training and validation. You can see we will split this training set further for training and validation. And after we finish training and validation, we will produce our final model, and then we will do our testing to our final model with this test set. Please be aware that during this training and validation process, many people call this validation set as test set. This can cause confusion because this test set really should be used at the last step for the testing, not here. So if you see somebody call test set during the validation process, you know really that means validation set. There are many validation methods we can use. Let's go through some of the popular validation methods. First one is called Holdout validation approach. This is the most basic method. It just split the total number of examples to training set and test set. Just like I mentioned, you see here we call it test set, but just remember this is for the validation, so maybe the better name should be validation set. Usually we use 70% of the data for training and 30% for testing, but you can use like 80% versus 20% at will. Another validation method is called k-fold cross-validation. In this method, you will split all the data set into k-fold, and you use one fold for testing and other k-1 fold for training. And you will move this one fold to different location. You will perform this cross-validation through this data set. Another method is called stratified k-fold cross-validation. This is very similar to k-fold cross-validation. The only difference is if you have a target class distribution. For example, in this one you have male this percentage and female this percentage, and then when you do the cross validation with this stratified k-fold cross validation, you will use the same percentage for each class for the testing. So that's why it is called stratified k-fold cross validation. Another validation method is called leave one out cross validation. That is one method that you will use one observation for the validation and for other observations for training. So the difference is not you separate the data to k-fold, but you use one observation for the validation. So leave one out cross-validation method will take longer time to do the training and the validation. I can show you when we run the Python code. Another validation method is called repeated random test train splits. This is similar to k-fold cross-validation, but the only difference is in this technique we create random split of the data in the training test set manner, and then repeat the process of splitting and evaluating the algorithm multiple times. You can see in this graph, first we will separate all the data set into certain data blocks, and then we'll pick up 4 blocks for test data. Other blocks will be used for train data, and then those 4 blocks of test data will be randomly chosen from the data set. You can see this data block is being used twice, and here also being used twice, but that's fine because we are using this random process. We just pick up 4 blocks of data as a test data, and then we repeat this process to do this repeated random test train splits. I'm going to use diabetes data for demonstration in this model. We have several features from the patients, and then we have the final outcome for this patient to show if the patient is diabetic or not. Those features have pregnancies, glucose, blood pressure, etc. Now let's go to the Python code to see how can we train and validate our model. First, I will load this diabetes data, and then I've used the validation method I mentioned to validate this model. The first one is holdout validation approach, and then k-fold cross-validation, and then stratified k-fold cross-validation. Next one is leave one out cross-validation. The last one is repeated random test train splits. Let's run the program. You can see we have all the features here, and we have the outcome here. We have 768 data points. As I mentioned before, you can see we got the result from holdout validation approach, k-fold cross-validation, and stratified k-fold cross-validation result very fast. Now we got leave one out cross-validation result. It took a long time because leave one out cross-validation method, we will use only one data point for the validation, and that means we will run this process for 768 times. And last one is repeated random test train splits. Let's check out the accuracy. You can see the best one is leave one out cross-validation. The accuracy is 77.6%. It's the highest. So we spent a long time for this calculation. It seems it's worth the time. This is how I perform machine learning validation with Python. Please provide your comments and subscribe to my YouTube channel. Thank you for watching.